Now, ladies and gentlemen, as we talk about the evolution of the universe, there was a point in time after the Big Bang and this constant expansion that occurred, that galaxies, which we've talked about in the past, galaxies, as you and I both know, evolve over time. That means they change. Now, there is a little bit of debate over what came first. Was it black holes or was it galaxies? And because black holes are beasts that are very difficult to see, we're not exactly sure. We know that there has to be a black hole in the beginning of galaxies. Some things you read, some things you say are going to say the black holes came and produced the galaxies, and then other sources say that the beginning galaxies were first produced, which led to the development of the first black holes. This is one of those questions that will be answered with more certainty, with more explanation, more explorations, more observations through time. But one way or another, early black holes produce those spiral galaxies or vice versa. And those spiral galaxies, as you and I know, collided, producing supermassive black holes at their centers, and then the multiple spirals combine to form ellipticals. So in the whole story of the cosmos, this evolution of galaxies is part of that story. This is leftover creations from that Big Bang leading to this. So time about 8.5 to 9 billion years after the Big Bang, which is 4.5 to 5 billion years ago, the first generation of stars had lived and died. Meaning these stars had formed, had lived out their life cycle. They had exploded, created nebula. The nebula had condensed down to form solar systems and stars and created solar systems like our own. If we had not had that first generation of stars made mostly of the primordial hydrogen and helium, they would not have created the heavy elements that you and I see today in our solar system and on our planet and within our bodies. Everything from calcium in our bones, iron in our blood, and gold and silver that we're wearing in jewelry. All of those things were created in that life cycle of stars. So we know that our star, due to its chemical composition, is either a second or third generation star. We don't really know how many times it's been through the whole life cycle of a star prior to this, but because it contains those heavy elements, we know that it has been recycled. It has given us the star that we have, the solar system we have, and our solar system has been stable long enough, 4.5 billion years, that life has had a chance to evolve. All the different forms of life on planet Earth, from bacteria to elephants to kitty cats and cute little kids. So one more picture, and I've given you lots of different illustrations of this Big Bang timeline because everyone shows slightly different things, and some speak to you more than others. So there was the Big Bang, which is this rapid era of expansion. The Planck era, this is anything prior to 10 to the negative 43 seconds, which at the moment we believe is the limit to how far back to the beginning of time we can actually reproduce or observe with our tools. Then we'll talk in this next couple of videos, we'll talk about the Grand Unification era. After that, in different assorted periods of time, elementary particles were produced like protons, neutrons, and before that, of course, even quarks. There was an era where elementary particles and antimatter was common, and we're still talking about fractions of a second after the Big Bang. These antimatter particles all annihilated each other in pure energy. So the amount of matter that was left is 1 part out of 10 billion, 1 atom out of every 10 billions that actually survive this matter-antimatter collision. Then we get a period of nucleosynthesis where you actually get nucleotides, which are going to be the nuclei of atoms that are produced. And all of this is within the first 3 minutes after the Big Bang. Protons, neutrons, electrons, and are produced. Eventually it cools to a point where hydrogen and helium get produced, the era of actual nuclei. That lasted a long, long, long time. Eventually atoms got produced where you had a nucleus and with electrons on the outside edge that could jump up and down in energy levels, giving us light. And this at that 380,000 years after the Big Bang, that is where we could actually see back to. Prior to that, it is opaque. There was the dark era, the era of atoms, this chart is calling it, but the dark era, which if there were stars there, we could see them, but we don't see any stars. Then, about 1 billion years ago, the first the first stars and the first galaxies formed. And as I've mentioned before, which came first, the black hole or the galaxy? Astronomers are still debating that. And from there on out to the present, we have this evolution of galaxies. So considering how complicated this is, the fact that we can know back to almost the exact first moments of creation of the universe, pretty monumental, pretty exciting. All right, that will end this one. And next we'll talk about, a challenge with Big Bang Theory.